So now that we have finished the volreg processing block in our script, so there was scrolling up here. There's the volreg block. If I go back down, we get to the blur block. Uh, Now that we've finished this, let's evaluate the registration in a little bit more detail. So going back to the AFNI controller, um, the bottom view is our T-shift result and the top view is our volreg result. So first of all, let's look at how the data looks in a ridge space. I'm going to set my underlay in T-shift. We had gone to run 3. I'm going to go back to run 1. So here's our run 1 T-shift results, and we still have the motion spike in there. And let's look at particularly the sagittal view. I'll throw that up here and make it a little bit bigger, and we can toss in our coronal image as well. So let's go a little bit more randomly in the center of the brain, so we not mid-sagittal but kind of in the center-ish, so we can see all 3 views pretty well. And we'll go to time point 1 in the time point 0, volume 1, the first volume in the control window, and pull back up the coronal image. And now in the graph window, let's just enter. I'll type a V to go into video mode, and we can just watch the volumes, see how they look. So it's scrolling through time a bit. Recall this subject was a little irritating because they didn't move enough, but at least there we saw our head motion. So at least we know that this data doesn't seem like it's corrected. And if I close the sagittal and coronal images, and now let's just open up similar ones in our volreg result. Let's make sure we're on run 1. Yep, we're on run PB02 run 1 volreg on top, and we'll open up a sagittal and coronal images there as well. And I guess I'll make this one a little bigger and put it next to the X, and I'll make the sagittal one bigger on the bottom. And now let's do the same thing. I'll go somewhat near, there's index 14. I'll go towards 42, and we can just watch 42 go by. And I'll hit V in the graph window for the volreg output. And you notice that you saw some motion there, but that was if we go back, that's an artifact. That's where our volreg results kind of fail. We can't. So it was corrected there. Let me jump back and forth. 40, 41, 42. So 42 is the one that gets corrupted. You see I'm bouncing back and forth between index 41 and 42. You see a change there, but this data has been volume registered. So as well as we reasonably can, we've corrected that motion, but it isn't as if the motion didn't happen. One thing to keep in mind is that a couple things to keep in mind is that one, motion isn't instantaneous. It's not like volume 41 was complete, then the subject moved their head by a degree or 2 degrees in this case, and then volume index 42 was acquired. It's not like that happens. What happens is, say a motion takes half a second, like a little hiccup or just a little jerk of the head takes a half or a quarter second. That affects slices differently. So slice 0, 2, 4, 6, 8, 10, 12 are acquired, but then 14 is a little rotated, 15 is more rotated, 16 is more, 18 is even more, and the rotation progresses. And then perhaps if it's a net head bob that returns to the original position, you might have slices coming back to the original position afterwards. So some of the slices are kind of in the right place, some of them are not. How does 3D volreg correct this? It can't. It can't account for the fact that the slices are acquired at different angles. even if you try to correct for that, you don't have data where you are supposed to have data. You can't pull data back in from where it was not acquired. So effectively, there's no way to fully correct for that motion. You just can't do it. So to some degree, that's why I call motion the bane of fMRI. This is something that's always going to be a problem, and you can't correct the data to make it as if the motion never happened. That would take infinite resolution data, or at least resolution that's uh, basically what would be sufficient to call full resolution relative to the anatomical fluctuations. The variance in how the magnitudes change over space. Anyway, so we can't fix it. That head motion will forever corrupt our data, and that's why we tend to want to censor volumes that have high motion. But still, we can tell that even across at this time point, it looks like it's registered. So we've done what we can, and we'll keep the motion parameters as regressors of no interest. But again, this motion happened, and it does corrupt the data. So that's looking at the EPI over time. A couple other aspects, I'll close these two windows again. A couple other aspects to look at are like the EPI and anatomical registration. So I'm just going to mess around with controller A a bit, since that's in standard space. Or I could change B, since B will change later anyway, but whatever. So in controller A, I'm going to set my underlay to be anat final. That's the anatomy in standard space. And we can even open a couple more windows now. And now let's see how well we did aligning the EPI to that. So I'm going to set my overlay to be the final EPI volreg base min outlier. So this is the min outlier volume warped to the final space. So, oops, that was the underlay. So set the underlay back to anat final. Sorry. And we'll change the overlay to be the final EPI min outlier. So now we see the final EPI on top of the final anatomy. So how well do these overlap? Well, this isn't a great way to view it. The way I like to view it is actually turn off the overlay, and I'll toggle this define overlay panel to be closed so we regain some screen space. And we can adjust these windows to be a little bit bigger. Where did that go? Where's my axial image window? So I right-clicked on the image window, since something I did lost it with these new fangled modern desktops that try to be intelligent to do things you don't like. Oops. Just making these a little bit bigger. Okay, so that's great. So now we've got our underlay to be the anat final, and the overlay to be the final EPI. I should have called this EPI final, but tough luck. It's nice to have. Well, actually, final EPI is better. It's nice to have final first, because then we can look for all the finals together. But anyway, this is what we have. Now we can use the O key would toggle on and off the overlay, but that's not the best. That's not such a great way to view this. I prefer toggling the U key, and then you can bounce back and forth between the anat and EPI and see if the contours match. So, for example, in the sagittal image here, we've got this we've got the CSF following the gray matter down in this little curve here. If we toggle the underlay to be the EPI, we should see a bright pattern matching that, because the bright is the most bright part of the EPI image is the CSF, and CSF is dark here, so the dark anatomy, the dark T1 should register with the bright EPI, and you can see that looks really good there. Up in here, you can see you should have a couple bright fingers coming down, and you can see it right there. I'm kind of in the mouse is kind of in the middle where it's dark. That looks great. Just bouncing a couple other places. If we go over here, we should see this area be bright, so a bright area coming here and then curving around. Yeah, we see a blob there. It's not perfect. You see, like right in here, it ought to be bright, but there's a dark spot in there. No, that's just a different. I don't know what the actual tissue or whatever you want to call it is in there. Here are the ventricles. The ventricles, we have some bright spots right there. That looks good. Over here, you know, I'm not even clicking the mouse. I'm just putting the mouse somewhere to direct your eyes. This blob over here. And one thing you can look for, sometimes we evaluate right versus left. Here you see an asymmetry between the left and right in terms of the folding patterns. This goes in higher up, and this has that went in up there, and it goes in down here. If we toggle the U key, the brightness patterns kind of match that a little better. If this were left-right flip, we should. That's one spot where we might be able to detect it, or even just to go to. Let's go to a couple random places in the brain. Here's another spot. This should be lower than that, and we should see, I don't know if this is the most clear spot. These are a little bit too symmetric for to make a nice point. I guess that should be obvious enough. The mid-sagittal areas are generally helpful. You see how these line up very nicely. But if there were a left-right flip issue, you'd be able to detect it with that. These outer regions are a little harder to detect. Well, this should be one blob and this two blobs, but even these two blobs might kind of match those two, so that's a little harder to tell there. But anyway, this looks great. Looking at each one of the four of these, you can actually see the registration looks fantastic. So the other thing that I wanted to look at is the extents mask that we created. So what does that actually look like? If we put the extents mask over the EPI, it'll just blot out the data. So it's more useful to put the extents mask on top of the anatomy. So where is our mask EPI extents? Okay, that's a suspiciously named volume. If we turn this on, what does it look like? Well, great, a big rectangular blob, so that's pretty useless, right? No, not really. How do you get this? If you take an EPI volume and you align, you know, it's gone through registration steps, and these are all affine registrations. So it's all shifts, rotations, and stretches. That's all that have been applied to this. So basically, this ought to look like a shoebox sitting on top of the anatomy. It could be at an angle, but it still should be a shoebox. And what you can see actually right here in the sagittal image is it's no longer just a shoebox. The top and the bottom slices look basically parallel here. That's great. That would qualify as a shoebox sitting in standard space, but left and right is not parallel. This could be truncated, but this is no longer a right angle. That's a little acute, and this is more obtuse down on the bottom. So since that's not a right angle, it looks to me like some of this has been chopped off due to head motion. You know, for example, this side over here, you know, the head motion, the subject nodded their head. So maybe this could be chopped off over here, or the top and bottom, I don't know. Whatever. Something gets chopped off, possibly multiple regions get chopped off a bit due to that head motion. And I'll just hop around a little bit and go to another random spot. And, it shouldn't look too different across space, but, anything where it looks like the lines have been pulled in a little more than you might expect, that may be due to the head motion. So this looks pretty much the same. So, I don't know. I'd have to really scrutinize it to see where the difference is. But this is the extents mask. Anything outside of this mask is where the all one data set, when warped to final space, had at least one time point where it lost data. And therefore, we chopped it out of the extents mask. So that's all this is. If this is a volume, a mask that says across all time points we should have data, valid data for our EPI time series. And then if the overlay is the EPI now, say run 1, oops, that was the underlay, you can see that if we go outside of the box, the EPI value should actually be in the volreg results. The EPI data should be 0 outside. So that's it. It looks like the alignment went pretty well. Underlay is EPI, overlay is the extents mask. So that seems good enough. It looks like the registration worked well. We can see the volreg registration was applied. We can see the anat and EPI are aligned. We didn't look at the anat aligned with the template. That can be done more as another subsequent step. We'll look at that with the QC perhaps. We don't have a copy of the template in this current directory. So let's stop here and then we'll move on after the volreg block.